Have you ever wondered how classes work in object-oriented programming? Today we're setting out to demystify this fundamental concept. In the world of OOP, a class is like a blueprint or a template. It defines the attributes, which are properties, and behaviors, which are methods that are common to all objects of a certain type. We'll be exploring the ins and outs of class declaration, touching on attributes and methods, and explaining object instantiation. We'll also delve into constructors, which are special methods used to initialize the attributes of an object when it's created. We won't forget to discuss inheritance, a concept that allows a class to inherit attributes and behaviors from another class. And finally, we'll look at encapsulation, access modifiers, and polymorphism. Now that we have our roadmap, we can dive into these concepts one by one. To start, we need to understand class declaration and attributes. In the realm of object-oriented programming, declaring a class is like drawing up the blueprint for a building. It's where we define the structure and capabilities of a particular type of object. The syntax for declaring a class is quite straightforward. We simply use the keyword class, followed by the name of the class, and a colon. Inside this class, we can define attributes and methods. Attributes, sometimes referred to as data members or fields, are the variables that hold the data or properties associated with objects of the class. For instance, if we were to declare a class called person, we might define attributes such as name and age. These attributes would then hold the data for the name and age of any person object we create. Attributes are incredibly important because they give our objects state. Think of them as the building blocks of our objects, the raw materials from which we construct our program. Without attributes, our objects would be empty shells, devoid of any information or substance. Let's delve a little deeper with an example. Consider the class person again. We define it using the class keyword, give it the name person, and then inside the class we define our attributes. In this case, name and age. We use the equal sign to assign a default value to these attributes. For name, we might assign an empty string, and for age, we might assign the number 0. So, to recap, class declaration is the process of defining a new type of object, including its attributes and methods. Attributes are the properties or data associated with each object of that class. They provide the objects with their state, making them more than just empty shells. By understanding class declaration and attributes, we're laying the foundation for building complex functional programs. With class declaration and attributes under our belt, we can move on to methods. Scene script. Methods are the engines that drive our classes. These are the actions or behaviors that the objects of our classes can perform. In essence, methods are functions that are associated with a class. Think of a calculator class, for instance. To make it useful, we'd need methods like add and subtract. In Python, we define these methods within our class. Each method has a unique name and is defined with the def keyword, followed by the method name. Following the name, we have parentheses that may include parameters that the method will use. An important parameter that every method has is self. The self parameter refers to the instance of the class and is used to access variables that belongs to the class. So when we write a method like add, we're saying that an object from the calculator class can perform this action. It's like giving abilities to our objects. But how do we bring these objects to life? This is where object instantiation comes in. Instantiation is a fancy term for creating a new, unique instance of a class. In other words, it's how we create a new object from our class. Once we've defined our class with all its attributes and methods, creating an object is as simple as calling the class name followed by parentheses. For example, if we have a class named person, we can create an instance of person. Let's call it person1 by simply writing person1 equals sign person. Now, person1 is an object of the person class. This person1 object now has all the attributes and methods that we defined in the person class. And just like that, we've breathed life into our class by creating an object. This new object can now interact with its environment using the methods we've defined. In the world of programming, methods and objects are like verbs and nouns. Methods are the actions, the verbs, and objects are the things, the nouns. Together, they form the sentences that make up our programs. Now that we know how to create objects, let's talk about how to initialize them. Constructors play a crucial role in setting up our objects. They are the special methods that are called when we create a new instance of a class, and their job is to initialize that instance's attributes. You can think of constructors as the setup crew for your objects, getting everything in place for them to function properly. In a language like Python, constructors are defined using the def keyword, followed by a $_init__ method. It's a bit of a mouthful, so we usually just call it the init method. This method allows us to set the initial state of our objects by assigning values to their attributes. Let's consider our person class from earlier. We can add a constructor to it that takes 2 parameters, name and age. This way, whenever we create a new person object, we can immediately assign them a name and an age, like this: person 1 = person, John, 30. Now, person 1 is a new instance of the person class with the name John and the age 30. Now, let's switch gears and talk about inheritance, another fundamental concept in object-oriented programming. Inheritance is a way for us to create a new class, known as a subclass, that inherits the attributes and methods of an existing class, referred to as the superclass. Think of it as a family tree. The superclass is like the parent, and the subclass is like the child. The child inherits certain traits from their parent. Similarly, a subclass inherits attributes and methods from its superclass. For instance, we could have a student class that inherits from our person class. This means that student would automatically have a name and an age, just like person. But we could also add new attributes or methods specific to students, such as major or study. Inheritance is a powerful tool that allows us to write more modular and maintainable code by reducing redundancy and promoting reuse. With a grasp on inheritance, we can now delve into encapsulation. Encapsulation is a fundamental principle in OOP. It's a bit like packing a suitcase where you bundle your data and methods together in one neat package, or in this case, a class. The real beauty of encapsulation is that it hides the internal details of the class. It's like having a secret compartment in your suitcase that only you know about. This keeps your code clean, organized, and easy to maintain. Now, how do we control who gets to see what's in our suitcase? This is where access modifiers come into play. Think of them as the locks on your suitcase. We have 3 types of locks, or access modifiers: public, private, and protected. Public members are like those items in your suitcase that you don't mind others seeing. They're accessible from outside the class. Private members, however, are your secret items. They're accessible only within the class. Lastly, we have protected members. These are accessible within the class and its subclasses, like a lock that opens for you and your trusted companions. Now let's talk about polymorphism. If encapsulation is like packing a suitcase, polymorphism is like having a magical suitcase that can change its form to suit your needs. It allows objects of different classes to be treated as objects of a common base class. This gives you flexibility and makes your code more intuitive. For instance, you could have a shape class and subclasses like circle, square, etc. With polymorphism, you can call a draw method on a shape object without worrying about whether it's a circle, square, or any other shape. The right method gets called based on the actual object, not the reference type. With these concepts, you are now well equipped to tackle classes in OOP. Let's take a moment to reflect on what we've learned. We started with the basics of classes in object-oriented programming, where we saw that a class is a blueprint that defines the attributes and behaviors common to all objects of a certain type. We discussed class declaration and how it involves defining attributes and methods, which represent the properties and actions of the objects respectively. We then delved into object instantiation, the process of creating instances of a class. We also talked about constructors, special methods used to initialize the attributes of an object. We explored the concept of inheritance, a feature that allows a class to inherit attributes and behaviors from another class. We also covered encapsulation, which bundles data and methods into a single unit, and access modifiers, which control the visibility of these attributes and methods. Lastly, we touched on polymorphism, which allows objects of different classes to be treated as objects of a common base class. Thank you for joining this journey through classes in OOP. Until next time, happy coding!